Hi, this is Dr. Green. We're working on Web Assigned Homework 8 and problem number 8. So in this problem, a professor wants to test and see whether the day of week that an exam is taken, Monday, Wednesday, or Friday, whether or not that is independent of exam grades as pass-fail. So the following table here shows your observed frequencies. So he observed the days of the week and then the pass-fail status, and then totals on the bottom, total on the side. They ask us to conduct a chi-squared test of independence at the 0.05 level of significance. So this is similar to the other chi-squared test. In fact, the test statistic is computed the same way, the same formula. It's just a little bit different in terms of how you compute the expected frequencies. So we've done that once, so I'm going to concentrate on using SPSS to do this for us. So I've already coded in the data. Let me show you that. So here is the data in SPSS. I've got two nominal variables, exam and day. And if you look at the variable view for exam, I've got that coded as nominal here. And the same thing for day, that's nominal. And then I also put some values in. So the exam values, I clicked on the values column in the tab to the right. I've got 1 for pass here, and then 2 equals fail. So I just type in 2 equals fail, and I clicked add it. And then for the day variable here, I coded in 1 is Monday, 2 is Wednesday, and 3 is Friday. So let's go back to our data view. And then the counts here, so this is an exam status of pass, a 1, and then the days are Monday, Wednesday, Friday. So pass here is a 1, fail is a 2, Monday's a 1, Wednesday's a 2, and Friday is a 3. So in my first 3 entries here, I've got pass on the exam and Monday, Wednesday, Friday for the day, 20, 22, 14. So that's this first row. Pass on the exam, Monday, Wednesday, Friday for the day, 1 with 1, 2, 3. And then in the second part of the table, I've got 3 2s for exam status. That is a fail on Monday, Wednesday, or Friday, and then the counts 8, 10, 16. So fail is a 2, Monday, Wednesday, Friday is my 1, 2, 3, 8, 10, 16. So once you've got the data coded in, then you want to weight the cases by the counts here. So I'm going to do data, weight cases all the way to the bottom, so off the end of your screen, and then make sure that the count is over here. So if count's over here, then go ahead and bring it over. Click weight cases by and then bring it over. Click OK, and then go back to your data. And then you want to do analyze, descriptive statistics, and crosstabs. And then when you do, if your exam and day are over here, then move those over. Remember, the pass-fail status exam is your row, and then the day is your column. So move those over. Click on statistics. Make sure that chi-squared is checked here, and then click continue and click OK. So here's our data. So we've got the cross tabulation for exam and day, and that should exactly match what's here. And in fact, I brought it over, and it does 20, 22, 14 here, 8, 10, and 16 here. And then the chi-square test results are the table just below that. So that's this table, and I went ahead and brought that over here too. So they want to know, what is the test statistic chi-squared? That is right here, Pearson chi-square. Here's our test statistic, 4.678. They're having us round to 2 decimal places, so it would be 4.68. And then they want to know, do we retain or reject the null? Well, look at your two-sided significance here. This is your p-value, and ours is 0.096. And we treat this as a two-sided test. That 0.096 is greater than 0.05, so we are going to retain the null. And the SPSS steps to do this are listed down here underneath the problem. Same steps that we used in the previous problem. So then in part B here, we want to compute the effect size here using Kramer's V. And here's the formula for Kramer's V, and that is on the exam 3 formula sheet. And so we take the chi-squared test statistic, that 4.68, and we put that up on top. And then down underneath, we take the total sample size n, and that is the 90 right here, grand total in the table. And then we multiply that by the smaller degree of freedom. And the degrees of freedom are column -1 and row -1. So there were 2 columns and there were 3 rows. So between 2 - 1 and 3 - 1, so that's 1 and 2. Those are our degrees of freedom. And we are going to pick the smaller of those, which is the 1. So this is the square root of 4.68 over 90. And if you key that into the calculator, you will get 0.23 to 2 decimal places. And that finishes that problem.